So in class we talked about classifying pollutants by what they do. And today in this video we're going to talk about classifying pollutants by what they are. So this is more chemically speaking and probably remind you more about the chemistry that you've had in the past. So in this video we're just going to talk about inorganic, and then there'll be one more video for organic, and then we'll talk about the remaining three in class. So first, inorganic, that's essentially metals and anions are the two big ones. So metals are naturally occurring, they're elements. They exist in nature. We just redistribute them and increase their availability through things like mining. We increase lead, cadmium, and copper availability. E-waste has a lot of metals: lead, cadmium, zinc, mercury, copper, manganese, and even road dust. So we get copper from brakes, zinc from tires, and then motor oil can absorb these metals and sort of spread them around. So when we're talking about metals, you'll often hear people talk about anthropogenic enrichment factors. So this just gives us an idea of how much humans have to do with the availability of these metals. So we start with the size of the anthropogenic or human source, and all of these values are in 10 to the 6 or times 10 to the 6 kilograms per year. So this 8 would be 8 times 10 to the 6 kilograms per year. The natural source would be 1 times 10 to the 6 kilograms per year, and the total amount would just be adding these two together. That would be 9 times 10 to the 6 kilograms per year. So the anthropogenic enrichment factor, or AEF, you'll see it abbreviated that way in the reading. It's just the human source. So in this case for cadmium, that's 8 divided by the total size of the source yearly, and then multiply that by 100 to get a percentage. So 89% of the yearly source is due to human activity. And you can see moving down the line that we have a large impact in cadmium availability, lead availability, zinc, mercury, not much less of a role in making manganese available. Okay, so quick review for you. Human activity is more important for the availability of mercury, that has an anthropogenic enrichment factor of 66%, or for manganese, which has an anthropogenic enrichment factor of 12. So you can pause and think about that, maybe go back to the last slide and see what the answer is. Or if you already know, just continue. Right, so it's mercury, right? So we have a much bigger impact on the availability of mercury. So 66% of the yearly source is due to human activity, whereas only 12% of manganese availability is due to human activity. Okay, so this is just to show you, kind of put metals in context from your chemistry background. Pretty much all of these silver elements here, they're all considered metals. The green ones here are metalloids, so they're kind of in between metals and non-metals. And then only the browns here are non-metals. So metals are actually classified into 3 different categories. There are Class A, the purple ones here, and Class B, the yellow, and then borderline, which are green. So Class A are hard metals that lose electrons to form cations. These are probably things that you've seen before, particularly if you've had a soils class. Calcium right here, potassium here, and magnesium here. They all form cations and kind of attach themselves to soil. We'll talk about that later. So they can also form salts with anions. That's their main form. So in Class B, we have soft metals. They form covalent bonds and compounds. So this, again, it's these yellow ones down here. And a big one is mercury. You've probably heard a little bit about that already. And mercury starts out as a cation, but then it forms bonds with carbon, like CH3, here to form methylmercury, which is actually where it begins to get really toxic and cause problems in the food web. And you probably talked about that a little bit already in your previous classes. We may talk about it a little bit more later on, more the chemistry of it. So borderline are these intermediate metals that have a tendency have tendencies from both classes, so cations and then forming carbon compounds as well. And again, they're the green ones. Okay, so anions you might be more familiar with. You've probably talked about the impacts of anions, things like nitrate and phosphate. So they're not toxic. And in fact, plants and animals and you and me, we need these compounds. We need nitrogen, we need phosphorus to be healthy and happy. But in abundance, they cause problems. So they alleviate nutrient limitation and can cause things like big algae blooms, often toxic algae blooms. And these are just pictures from last year, the outbreak in Lake Erie that was so toxic that they put a ban on all drinking water in the city of Toledo for quite some time. And you probably know we have some problems with this as well in Vermont with Lake Champlain and some outbreaks there. Okay, so the next video will talk about organic pollutants, and that is the end of inorganic. And we'll talk a little bit more about these sorts of things, maybe more applied knowledge in class. But thanks for watching.